In late 2023, a scientific team from the University of Kansas Medical Center launched 40 female mice to the International Space Station aboard the SpaceX mission CRS-29 in cooperation with NASA. The mice were part of NASA's Rodent Research-20 experiment, the very last of a series of rodent biology missions spanning back to 2014, and would fly in space for 6 weeks. This was the last experiment that would ever fly on the ISS to study mammalian reproduction factors in space, before the station is scheduled to be deorbited in 2030. It was the most thorough experiment ever conducted by NASA on how microgravity conditions impact female reproductive biology. Why is that so important? Because studying mammalian reproductive biology in space helps us better understand and prepare for challenges and dangers that will be posed to our own human reproductive capacities in off-Earth environments of the future. If we can't safely have babies beyond our home planet, then we'll never be able to truly settle new worlds like Mars. Studying these impacts also helps us better understand and optimize human fertility and reproductive health here on Earth, at a time when fertility rates are falling across the world.
So if we actually want to see a thriving city on Mars someday, for example, this particular area of knowledge is going to be indispensable. There really is no getting around that fact.
The mice flew for 42 days aboard the ISS, returning to Earth on December 22, 2023. Of the original 40 female mice that flew in space, 20 were mated with male ground controls after their return. The mice successfully reproduced, creating a new generation of mice who would go on to have offspring of their own. It was at that point that the research team made a groundbreaking discovery. Their initial findings revealed that while the children of the space-flown mice showed no significant impacts from their mother's spaceflight exposure, the grandchildren mice showed a significantly altered phenotype. This was a result of their genotype, or genetic code, having been exposed to space through their grandmother's gametes.
As we travel into space in the future, we can expect that our own genetics are going to see similar impacts, and that we will develop phenotypes as those mice did. We're very close in our overall DNA structure to these mice.
This suggests that long-term exposure to space environments could significantly impact and possibly even alter our genetic code as humans in the future.
Analyzing this data will likely help us make significant strides in the fields of genetics, epigenetics, cancer research, obesity, longevity medicine. Really, human health writ large stands to benefit enormously from the data that has been collected from these mice.
But then, in the fall of 2024, the research team at KUMC received dire news from NASA. Due to Space Life Sciences budget cuts, NASA wouldn't be able to extend the team's grant to continue studying the space mice offspring. The principal investigator and leader of the research team, Dr. Lane Christensen, then reached out to the Advanced SpaceLife Research Institute, the first of its kind nonprofit research organization based in Cape Canaveral, Florida, to see if they would have any interest in sponsoring the continuation of Rodent Research-20.
ASRI as an institution was designed specifically to study human sexual health and reproduction factors applied to outer space. Rodent Research-20 as an experiment represents the tail end of decades of the rodent research series. So there was over a decade of time that was invested, at least $16 million of taxpayer money. Obviously, the flight to the International Space Station, the time in space, and all the post-analysis that has happened since. Right now, where the experiment sits is the team is only beginning to make their most exciting findings. So while we were not able to directly fund the project when they first approached us, we did agree that we would do everything in our power to help raise the funds that would be necessary to sustain the mice and the future of the research itself. A big part of what ASRI is currently looking to accomplish is mapping out what all the challenges that humanity faces in off-world environments when it comes to reproduction, when it comes to sexual health, and be able to develop viable solutions to meet those challenges for the species.
With the small remainder of funds currently supporting the mice rapidly running out, the colony faces potential euthanization, as the research team won't have the financial means to maintain them, meaning that their lives, as well as any data from potential future generations of these exceptionally special mice, could soon be lost forever.
If we lose these mice now, after all the time and effort and taxpayer investment, we have really effectively lost what is a 10-year head start as a species in this area of research, and we're not going to be able to settle new worlds without it. I would say that perhaps the most important thing that we can do to secure the future of this research right now, the future of humanity in space, is coming together to save Rodent Research-20.